Hi, and welcome to the video on naming ionic compounds with transition metals. We're going to look at going from the chemical formula to the name, or going from the name to the chemical formula. So when we say transition metals, let's first explain what I mean by that. Transition metals are the metals in the middle of the periodic table in the D block section. They're called transition metals. And the thing to know about transition metals is that they have variable charges, which means you can't predict by looking at where the metal is in the periodic table what its charge going to be. For example, copper could have a +1 charge or a +2 charge or a +3 charge. You can't tell from looking at it. And that's unlike the other metals, like group 1 metals, which have +1s, and group 2s, which have +2s, and group 13s, which have +3s, where you can just tell from where it is in the periodic table what's the charge going to be. The only exception of transition metals that actually you can tell what their charges are, silver and zinc. They just have a common charge. Silver is +1 and zinc is +2. But for the rest of them, you actually have to figure out the charge based on its chemical formula or information in the name. So let's take a look at this first example. We're asked to write, in this case, since we're given the chemical formula, we need to write the name of this. So the process is the same as you saw in part 1. Remember, this is sort of divided into two parts, your cation, which is usually the metal, and that's written first, so copper, Cu, and then your non-metal part, SO4. And I like to do this because it sort of helps me figure out where do I look to find the information to name the cation and anion. All right, so first thing is we have copper, Cu. And if I didn't know it was Cu, if it's my cation, I'm most likely looking in the periodic table to figure out the name. Okay, so here we go. There goes copper. Cu is copper. Okay, so just go ahead and write that in, okay? And I'm going to leave a little bit of space here in a second. Okay, so this is copper. And you'll see why in a moment. Now we're going to go for the next one, SO4. So notice that there's more than one type of element. So should I look on the periodic table to find the name? Or should I look at my polyatomics? Well, if there's more than one type of element, it's going to be on the polyatomics. So I'm looking for something that begins with S, and I'm scrolling down. No S here, no S here, blah, blah, blah. There we go. We've got some S's. SO42 minus, that's sulfate. So this is called sulfate. And leave some space in between when you're doing the ones with transition metals. Okay? So if your metal is a transition metal and you're doing the name, right? So if it's one of the metals in the middle of the block, make sure you leave some space. Okay. So now what's going to go in that space? Remember how I said copper can have different charges? It can be +1, it can be +2, it can be +3 or whatever. What you're going to do is you are going to put next to copper in parentheses the charge on copper. And you're going to figure that out based on the chemical formula. So how do we figure that out? We know the overall charge of this chemical formula must be 0. And we don't know the charge of copper, but we do know the charge of sulfate because if you look on the chart here, it's 2-. So that means that we've got a -2 charge, okay? So I'm going to ask myself, what charge of copper plus -2 will give me 0? Well, what plus -2 gives you 0? That means it's +2. So my copper must have a +2 charge. Okay? Now, when I write the charge, though, I'm not going to write a 2. And the reason why I'm not going to use what I believe are called canonical numbers is because we use those type of numbers for our subscripts. Okay? So to make it clear, instead of writing these canonical numbers, what we're going to do is we are going to write Roman numerals. Okay, so the Roman numeral for 2 is like 2 I's, right? So I'm going to go ahead and put that in there. So copper 2 sulfate. Okay, let's go ahead and try it for this next example. The same thing. First thing I like to do is break this apart. So what's written first, Fe, is my metal, and I can find that in the periodic table. It's Fe is iron. Okay, so transition metal, it's in that middle block there. So I'm going to write that out, iron. Again, I'm going to leave some space. And if you want, you can just start putting your parentheses because now you know for transition metals, you need to put the charge in Roman numerals in parentheses. Okay. Now in the next part here, I have Br, and there are 3 of them. Now, even though there are 3 of them, I'm still going to look in the periodic table because there's only one type of nonmetal here. So there's only one type of nonmetal atom. Where here I had a sulfur and an oxygen. Those are two different types of nonmetal atoms. Okay, and here I just have bromine. So I'm going to look on the periodic table for that. And so Br is bromine. And remember, if you're using the one on the periodic table, you have to drop the ending, that last syllable, and replace it with "ide." Okay, so that becomes bromide. So from bromine to bromide. Okay, so now I have iron blank bromide. Okay, next step is to figure out what's the charge of my iron. So remember, the overall charge of this formula needs to be 0. Okay, I don't know the charge of the transition metal because that could be anything, but I can figure it out based on the charge of my anion. So bromine is here in group 17, okay? And remember, group 17 has a -1 charge. All of these have a -1 charge. So we know that each bromine has a -1 charge, but the subscript down here tells me that there are 3 of them. Okay? So that means I have an overall -3 charge from the bromine, okay? So now I'm asking myself, well, what, question mark, plus -3, since I only have one iron here, makes it a little easy, what plus -3 will give me 0 charge? And the answer to that, of course, would be +3. So that means that iron is going to be +3. Right over here. My iron is +3, which in Roman numerals is 1, 2, 3, 3 I's. Okay. So what I have here, remember, is inside the Roman numeral, inside parentheses, in Roman numerals, you have the charge on the metal. Okay, that's what that number represents. All right, let's do this in reverse. Let's do this in a flip way. So we have chromium sulfate. Now we're given the name and we need to write the chemical formula. So this is the same thing that we sort of did before, but in this case, the only difference from what we did in part 2 is instead of using the periodic table to figure out the charges of the metals, you're going to use what's written in Roman numerals, in parentheses in Roman numerals, to get the charge. All right, so let's begin. Chromium, that's written first, so that's our metal. We're going to start in the periodic table and find it on the metal side. Here's chromium, Cr. So we know chromium is Cr. And the number in Roman numerals tells me the charge, so that's going to be +3 or 3+, however you want to write it. Okay, now I need to find my nonmetal part. My nonmetal part ends in 8, A-T-E. Okay, so if it ends in 8, that means I'm looking in the polyatomic chart, so sulfate. All right, and I'm going to look for something that begins with S. Scroll, 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 scroll. Not that one, not that one. Oh, there it goes, sulfate, SO4. Okay, and you got to be careful because there's also a sulfite, I-T-E ending, that is SO3. But we're looking at sulfate, which is SO4. Okay, so, and that has a -2 charge according to my polyatomic. Okay, so we've got a +3 and a -2. If you add them together, they're not going to give you 0. So in this case, I'm trying to figure out, well, how many of each of these do I need to get to 0? I can think of least common multiples here, and that would mean I would need 2 chromiums and 3 sulfurs. You can also just use the crisscross method, which is the charge of the anion will tell you how many cations you need, and the charge of the cation tells you how many anions you need. Okay, so with that being said, now I can write my formula. I start with chromium. I have Cr, and I'm going to need 2 of them. So this number does not stay in the front. It becomes its subscript, Cr. And then next I have SO4. And here's the thing we need to remember. This is a polyatomic, and we have 3 of them. When you have more than one polyatomic, put that in parentheses so that everyone knows that you have 3 of this group that stays together as a group, okay? So that's the chemical formula for chromium sulfate. All right, last one, titanium arsenide. All right, so again, we're going to start in the periodic table to find titanium. What is its element symbol? We're looking. We're dealing with transition metals here, so there it goes, titanium, Ti. All right, so the symbol for that is Ti. Now, where do I go to get the charge? Do I go look in the periodic table? Nope, not for transition metals. You look at what's in the Roman numerals in parentheses there. So that's there 2, Roman numeral 2. So that means I have a 2+ or +2 charge. And then for arsenide, It ends in IDE, so what does that tell you? Where do you go to find that? Do you go on the periodic table or the polyatomics? Well, if it's an IDE ending, that means you're going to look here. Okay, so arsenide. All right, so let's see if we can find arsenide. Here it is. And it's actually a metalloid. This is arsenic is a metalloid. But remember, metalloids react chemically like nonmetals. Okay, they look like metals, but they react like nonmetals. Okay, so we got our metalloid here, arsenic, which becomes arsenide when it's an anion. So the symbol here is AS. And now I need the charge. Okay, so let's figure that part out. Well, we're in the periodic table. We can use the periodic table to figure that out. It's in group 15, which has a -3 charge. Okay, and if you don't remember that, you want to use this pattern to sort of help you. So here it's in group 15. It has a -3 charge. All right, so now we have that information. So we can go ahead and start writing our chemical formula. And remember, we need to know how many of each of these that we have. So when I see +2 and -3, I know that I'm going to have a 3 for the one that has a +2 charge and a 2 for the one that has a -3 charge. So that when they add them together, we would have 3 times +2, which is +6, 2 times -3, which is -6, and when you add them together, give you an overall charge of 0. Again, you can also use the crisscross method, which if you take the charge of the anion, that gives you how many cations you need. So that would be 3 titaniums. And the charge of the cation will tell you how many anions you need, which means you need 2 arsenides, okay, or arsenic atoms. All right, so that's how you do it for the transition metals. The key thing is when you're writing the name, don't forget to put the charge of the transition metal in Roman numerals in parentheses next to it. And then when you're writing the chemical formula, use the charges in parentheses to determine the charge of the metal. All right, that is it for this video. You've got some more practice problems. Make sure you check and correct your answers. Hope you found it helpful. Have a quality day.